Swayam Prabha. Digital India. Educated India.
Okay. So, let us start. So, last class we have discussed about that different acoustics parameters of the room, liveliness, clarity, blendingness, all those things we have discussed. Then we have discussed how to calculate the reverberation time, mean free path, what is initial time gap, initial signal delay, and what should be the value, then percentage alcon, all those things we have defined. Now, we go for a practical implementation, which is auditorium acoustics. Suppose you want to design an auditorium or you want to design an lecture hall, that who are doing that architectural business, they design that lecture hall. How should I design that lecture hall so that acoustic is taken care? What are the parameters we should look for in case of acoustic treatment? So, there is two kinds of thing. One is that there is some architectural parameter for which we have to say that if I want a good acoustics, those architectural parameters should be like this, and then we have to provide a wide range of solution, or we have to provide a solution for acoustic treatment of the auditorium for better sound arrangement. Okay. So, now we discuss one by one. Let us auditorium, it is called auditorium acoustics. So, auditorium design has three part. One is the room acoustics, how do you treat the acoustics of that inside the auditorium, sound system, what kind of sound system I should use auditorium, so that ultimately aim is that in the auditorium every seat of that auditorium should receive that equal amount of sound. That is my ultimate objective. Okay. So, how to design that, what kind of sound system I should use, how it should be placed, all those things, and then noise control. How this my auditorium is free from external noise. If the external noise is entered in the auditorium, it hampers that auditorium acoustics, because environmental noise of the auditorium will be increased. So, which is destruct that sound system of the auditorium. So, we have to free from that external sound source. So, that is called noise control. We have to control the noise of the auditorium, so that by external noise should not enter in the auditorium. So, one by one we discuss all that issue, and then we will at the end we will go for a design class. Then architectural contribution to auditorium design. What architectural do? Room shape is defined by the architecture, volume and dimension is defined by the architecture, layout of boundary surface is also defined by the architecture, surface treatment, audience capacity, seating arrangement, all are the civil design parameters. When the auditorium is designed initially, they are considered, those are the parameters. Now, as an acoustic engineer, what kind of feedback you should provide to those architectural engineers, that yes, look, when you design an auditorium, due to the acoustics point of view, room shape, volume of the room, this should be look like this. So, those guideline is called the acoustical guideline to the architectural design. Okay. So, let us one by one discuss room shape. So, what is the acoustical requirement? Okay. Before coming to the room shape, let us start. What is acoustical requirement in auditorium design? There should be adequate loudness in every part of the auditorium, particularly the remote seat. So, what is my requirement is that at the end seat, if some audience is sitting, his loudness of that sound on that seat should be same as the loudness of the sound at the front seat. So, that then the design will be very good. So, I want there should be adequate loudness, means is that the last seat cannot hurt if the sound level is reduced, that should not be happen. So, adequate loudness should be provided in the last seat also, so that last seat people can also hear that sound. So, and The goal is that we should not waste the sound energy. So, reducing sound energy loss, how can we channelize the sound or how can we distribute the sound inside the whole auditorium is our goal. So, the auditorium should be shaped so that the audience is as close to the sound source as possible, as thereby the reducing the distance from distance the sound must travel. What is its meaning is that I want to design an auditorium so that everybody has a feeling that he is sitting close to the stage, because performance is happening on the stage. So, everybody should have a feeling that yes, I am close to the stage. What is the acoustical effect? Suppose there is only loudspeaker is placed in the front of the stage, then the sitting and the large distance, the direct sound will be less. Sitting in the front seat, direct sound will be high. So, I have to minimize the direct sound travel time to the last seat. That means, I have to minimize the distance from the stage to the each of the seat. How do I minimize it? Suppose if I design the auditorium room, that is the room shape, if I design the auditorium in second case, in this region. So, the centroid, the average distance between the stage and the seat, let us calculate it, is this. So, D2 is the centroid. See, the D2 will be large compared to D1 if I place the audience like this way, because that if this is a wide angle. So, the distance from the stage to the person is less. So, average distance will be reduced. Okay. So, everybody has a feeling that yes, I am close to the stage. Now, if you require a large capacity, you have to require a design, the length is very high, then use the balcony to reduce the length. Use the balcony to reduce the distance from the stage. Okay. So, there is some guideline in there. Then another one is that parallelism between the opposite sound reflecting boundary surface should be avoided to eliminate the. That means, it said that any auditorium must not have any parallel reflector. Okay. Suppose I make this auditorium or make this auditorium without this curve surface. Inside there is a curved surface. If this curved surface is not there, then this wall and this wall is parallel, which affect the sound quality. Okay, which undesirable reflection will come and standing wave will be generated. So, to reduce that, what I do, yes, this is a concrete wall, no problem, but I should make a inside arrangement such as the surface is curved. See that inside surface is curved to avoid the parallelism between the two reflecting surface. Okay. Similarly, I can do like this, change the shape, then it is parallelism is avoided, or I can do like this way, design the auditorium like this way. Okay. Why see that there is no parallel wall, or if it is rectangular, then inside the auditorium treat the wall such that it create a curved surface, which is required. Then what should be the shape of the auditorium? Volume and dimension of the auditorium. So, shape of the auditorium is discussed, that shape of there should not be two parallel wall, parallel reflecting surface, and the distance between the audience and stage must be minimized. So, to do that, what kind of arrangement is required, you have to do that. Mostly this fan shape is used with balcony if I have to design a large capacity auditorium. Okay. Now, volume and dimension, the floor area and the volume of the auditorium should be kept as a reasonably minimum, because unnecessary creating volume is not required, and it is architectural, it is a civil construction cost, also it reduces the sound energy. So, I have to minimize the volume, sorting the distance stage and people. So, that distance should be minimized. So, two parameters, optimum volume and optimum distance from the stage to the person is required. For that, I have to design the shape, and then I have to design the volume and dimension of the auditorium, what should be length, width, breadth, all kind of things. So, its thumb rule is that in audience size, floor area should be 6 to 8 square feet per seat. If there is a 100 seat, then 600 square feet to 800 square feet the floor area. Okay. Then recommended volume per seat, it depends on the type of the auditorium. It is for speech, then it is said the minimum, like the lecture theatre, it is 2.3, maximum 3.1, maximum 4.3 square feet per seat. Okay. Then 6.2, 7.8, 10.8 square feet per seat for a concert hall. For a picture theatre like cinema hall, it is 2.8, 3.5 is optimum, minimum is 2.8, and maximum is 5.1 is sufficient for the lecture hall, for a picture theatre, means cinema hall. So, you know the volume, and also the volume comes from the large room acoustics. The volume must be support the large room acoustics, so that the suppose you can say, okay, I have to design an auditorium for the 10 people, then the volume may be very small. So, that cannot support the large room acoustics, then I cannot design that large room acoustics design, which is followed by an auditorium design for that kind of room. Then we have to go for the small room acoustic design. Okay. So, this is minimum volume per seat, but thumb rule is that volume should support the large room acoustics. Then ceiling height, volume by floor area. Generally, it is 20 into multiplication of the reverberation time. So, it is volume, once I get the volume, then divided by the floor area. So, floor area I get per seat, I get the volume per seat, I calculate the volume and floor area, then I get the ceiling height. Then typically, the dimension will come in the L length, width and height is 2h, length should be twice than the height, width should be 1.5 times of the height, and height is h. So, if the height is 10 feet, let us 10 feet, then it should be 20 feet and 2 times 1.5 times, that means 15 feet and 10 feet, but the volume should support the large room acoustics. So, it may not be support the large room acoustics, so it cannot be a large room acoustics auditorium. So, minimum volume you have to say, I have to design for 200, I have to design for 200 capacity auditorium. So, 200 people, if I say the picture hall, that means cinema hall, then let us optimum value is 3.5. So, into 3.5 is the volume, minimum volume which is required, which is nothing but a 3.70 into 7 into 10 to the power, so 700 square feet, feet cube, okay, or meter cube, whatever is required. So, this is the minimum, or the feet cube is required, meter not meter cube. So, this is the minimum volume is required. Okay. So, you know that then how to design that, then I get the ceiling height, once I get the height, I have to design the floor area, that will come in this, almost come. Now, suppose in this formula, if your length is very long, suppose length is come 120, greater than 120 feet, then what will happen? It is increasing the direct sound distance. So, I have to reduce it. How can I reduce it? Use the balcony. If I use balcony, the length will be reduced. So, I can use the balcony, and stage opening should be this side. So, those are the basic parameter which is available from the literature, and I have given you. Then layout of the surface. How do I design the surface? This is, see that there is no parallel curve and there is a ramping here and balcony also ramped. So, why the ramp is required? The sound shore must be raised as much as feasible in order to secure the free flow of the direct sound. So, this is the one criteria, that if I want to put a loudspeaker in here, we should not be put in below the stage. It should be as raised as possible, so that the direct sound has a direct link with that last seat of the balcony. I have to see that if I put the box in here, let us I design an auditorium like this, and this is the balcony, and I put the sound loudspeaker in here. What will happen? there is no direct sound to this seat. So, this will affect. So, I raise the loudspeaker in here, so that sound is come here and here also. Okay, as much as possible. So, the direct sound reach the last seat of the balcony. Then another criteria, if I place that all seat in flat, so a human being is an observer of the sound. So, this man may foul the direct sound to the next man. So, direct sound cannot reach there. So, there is a ramping is required. This is also required for viewing, in viewing side also. So, there is a ramping is required, but this ramping has an limitation. I cannot ramp an auditorium like this. Okay. So, I ramp it 1:8 in ratio. So, if the length is 8 feet, then the ramp, last seat ramp should be 1 feet. If length is 100 feet, 1:8 ratio, I have to ramp it. So, I ramp it. Then how do you arrange the seating pattern? How do you arrange the seat? If I arrange a seat, suppose I put a seat in here and next seat in here, then what will happen? This man foul the direct sound to the next man. So, instead of doing that, you can make the seat arrangement like this picture. This man is sitting in gap between these two seats. So, there is a possibility the direct sound will be go there. Okay. So, this kind of seating pattern must be maintained. Then the sound source should be closely and close. So, okay, like this one. I don't want to read the slide. What is said that suppose I put a extra sound source in the wall or in the stage. Wherever I put the sound source, it should be covered by a reflector, or its sound source should be put in such area where the sound is reflective, so that it reinforces the reflection sound in the room. Okay. So, if I put an acoustic blanket in backside and then put a sound source, what will happen? If I put an acoustic blanket in here, so let us 100% absorptive. If I put a sound source here, so the sound which is supposed to come this side and reflected back to this side to increase the directivity will be absorbed. So, directivity cannot be 2, it comes 1, because the backside sound is absorbed instead of reflected into the front side, so that its reflected sound can travel to the audience, it is absorbed. So, if I put a loudspeaker in backside, if I required, then loudspeaker should be surrounded by a sound reflector, so that the reflection of the sound should reach to the audience. Okay. Next, time delay. This is very important. We have to think about that at least initial reflections to the audience should be reached within the 30 millisecond, which is nothing but a direct sound is d distance, then R sound is reflected sound is the R1 plus R2. So, R1 plus R2 minus d divided by 0.35. So, this is the distance time gap between the direct sound and first reflection. It should be within the 30 millisecond. Okay. So, how do you do it? So, the surface of the auditorium, if I say that or the top of the auditorium, the top surface of the auditorium must be not like a just plain ceiling. If I put a plain ceiling, what will happen? If I in top of the auditorium is just plain ceiling, then it will not create that equal reflection to all part of the auditorium. Instead of top ceiling, if I make a curved ceiling, I put a reflector in curved surface, or suppose my ceiling is flat, but I can put a reflector to make a curve, so that the reflection can happen in everywhere. Okay. So, unless what will happen, this reflection does not have a meaning, because if I want that is again reflected by the back surface and come to here, it may hard as a echo. So, this reflection, because backside will be treated as an acoustic blanket, so this will not reinforce the sound system. So, what I will do, I will make a curved reflector in the top ceiling, so that it reflects the sound. Okay. Unless the ceiling height is very high, always put reflector in the ceiling. If the ceiling height is very high, then what will happen? From the ceiling, reflection may create an echo. So, to avoid that echo, in that case I require a treatment of like the total absorptive surface in the ceiling, so that there is no reflection come from the ceiling if it is too high. If it is not that high, like that there is a possibility to have an echo, I can put a sound reflector there, so that it reinforces the reverberant sound. Okay. So, that kind of treatment I have to make. Now, there is a thumb rule of the surface treatment of the auditorium. So, near the stage it should be reflective, so that maximum energy is channelized to the audience. So, stage should be reflective, or near the stage and stage should be reflective. Next stage, middle portion should be diffusive, means there should be a irregular reflection from the surface, not regular reflection. If it is regular reflection, then what will happen? The some area will be focused and some area will be defocused. So, I want diffusive treatment after the stage, after the front part of the stage, let us that up to maybe few feet, that there will be a reflective surface. Then next portion is diffusive surface, and last portion should be absorptive. Why? Because if the length is long enough, then there may be a chance that I can harden echo. To avoid that, the last portion of the auditorium must be as much as absorptive, so that the reflection sound intensity is very low, so that the echo is avoided. So, when you design an auditorium, the acoustic treatment of the auditorium is reflective in the stage and front part of the auditorium. Middle part of the auditorium will be diffusive, and rear part of the auditorium, or the last part, rear part of the auditorium should be as possible as absorptive, so that no sound should be reflected from that area. Okay. So, that is the thumb rule for acoustic treatment in any auditorium. If you visited any good auditorium, you found that front part of the stage are made of a polished wood and some channel. So, the channel create an diffusive reflection, and it is a reflective, glazy. So, glazy means reflection coefficient is very high. There is no acoustic style is placed on the front part of the stage, or few portions after stage there is a few meters, or you can 1 or 3 meters, there will be all reflective surface. Then next part is diffusive. So, there is a acoustic diffuser is placed, as we discussed in the last class, the acoustic diffuser. How do you know that? You know that acoustic diffuser is a irregular surface, and you know what kind of acoustic diffuser is available in the market. You can go to the market and see that what kind of acoustic diffuser. So, the diffusive surface, not regular surface. If I make a wall of the auditorium painted, glazy painted in the surface, then what will happen? It creates a regular reflection. So, that is why auditorium, inside the auditorium you do not find that, except stage part, that there is a glazy surface which can produce a regular reflection. There is a reflector, but it is diffuse reflector. That means, it creates an irregular reflection. So, instead of plain painted wall, we use a rough wall kind of things to provide a diffuse reflection. Okay. So, there is a material provide surface irregularity, random, alternative. So, I can see there is some moral. If you see in visit an auditorium, sometimes in the front part of the stage there is some moral. Since moral has an uneven surface, it can act as diffuse reflection, and moral is painted, then the absorptivity of the moral is very less. So, front part of the stage is reflective. So, I can do some moral or wooden work in the front part of the stage. If you visit in our here Kalidas auditorium, you see the front part is made painted wooden design. So, it is a irregular diffuse design, but it is a reflection coefficient is much higher, so that it reflects the maximum energy. But after that, we put some acoustic styles, which is an acoustic diffuser, so that it creates a diffuse reflection. But in the rear part of the auditorium, we should treat total absorptive. That means, the material whose absorption coefficient is very high should be put in the rear part of the auditorium. Now, the room must maintain optimum reverberation characteristics, the reverberation time must allow favorable reception and efficient presentation. So, I cannot say that okay, I make a auditorium whose reverberation time is very less and whose reverberation time is very high, both are problematic. So, I have already said give you a slides where I said that different kind of purpose of the auditorium, if its purpose is speech theatre, if its purpose is concert hall, what should be the optimum reverberation side time, that there is a chart available from the architectural design side. Okay. Then the room should be free from acoustical defects such as echo, long delay reflection, sound concentration and coupled space. That means, what is the meaning? When I get an echo, if the delay between the direct sound and reverberation sound is much high, then there is a possibility that I heard an echo. So, suppose my room has a long distance, long end room, if the end reflection come to me, then I may heard as an echo. Then what I do? At the end part of the auditorium, I must put absorptive material so that the maximum sound energy is absorbed by the surface. So, the reflection sound intensity is very low, then I can avoid that echo, the echo will be not there. Or I can change the shape. If you see the shape of the rear part, if I design a auditorium ceiling such that no sound energy can receive here and or the minimum sound energy will be reached in that last portion of the auditorium, then I can tap that end part. So, the volume of the rear part is reduced to reduce the number of reflection. Okay. Then I can make a rear wall acoustic blanket kind of arrangement, so that even if the reflection is come, it totally absorbed. Even if the direct sound is fall on that wall, it is totally absorbed. So, if you visit any auditorium, you should see the end wall or the rear wall of the auditorium will be treated with an acoustic blanket or a material which has high absorptivity. Okay. If the primary sound source which is normally located in the front part of the auditorium, so suppose I want to put, you can read the slide, I am not reading the slide. So, suppose you want to put an extra loudspeaker in the auditorium. So, as I mentioned, when I put the extra loudspeaker, I should put with a reflective surface, so that the sound energy of the loudspeaker is reflected back to the auditorium. Okay. So, I put a reflective surface. Noise, external noise is very important. Suppose you are creating a AC dark in the auditorium, you should very cautious that acoustic through the acoustic dark, external sound should not enter in the auditorium. So, there is within the dark also you require an acoustic treatment, so that external noise is avoided through the AC dark also. And also you have to see, suppose I build an auditorium beside a highway, what will happen? The highway sound will be, there is a vibration, conduct sound will be there. Conduct sound means, say let us you put that wall thick, so that the external sound not enter the auditorium, then you put a acoustic blanket, after that then you put the acoustic reflector. So, the inside sound is reflected back, but outside sound cannot enter because there is a acoustic blanket and there is a brick wall. If you have heard about the intensity, transmitted intensity is inversely proportional to the L square. So, I can, if the length of that wall is increases, then the very rare sound intensity will be enter in the auditorium. So, I can say that yes, I can make that arrangement so that highway noise is not entered. But if it is totally concrete to the highway, what will happen? The vibration, conduction noise will come out. So, to avoid that I should make an arrangement so that auditorium is separated from that conduction. So, I can make a channel outside the auditorium and put a sand there. So, it acts as an absorber and the direct sound will not come. Similarly, in the floor, how to treat a floor of the auditorium, you found that generally the auditorium floor is carpet. Why? Because we want that there is two kind of things. If it is not glossy surface, there will be a reflection from the surface. Okay. So, that audience also create a noise, that noise also reflected. Okay. So, I want the auditorium that the diffuse, see the I require a diffuser in the middle portion. So, instead of providing a middle portion only blanket, I provide whole auditorium is a soft acoustic carpet, so that reflection sound does not come. But the stage I require a reflective surface, so I can make a concrete stage with a high reflective coefficient, or the front of the stage also I can make a high reflective coefficient. So, I can make a concrete on that area which is a high reflective coefficient. But in the rear part, in the floor also has to be treated as either diffusive, and the in the rear part I have to treat that floor also whose absorption coefficient is very high. So, that is nothing but a carpet. Okay. So, there is an example, okay, don't forget about that. There is an example I have given in here. Say that I think it is not visible. So, let us I make it large. What I said that an auditorium has in the following specification design it acoustic treatment. What is there? I given a table, people and uphold seat, quantity I have not, vacant seat. So, there is a all absorption coefficient is given in table 1, absorption coefficient of a vacant seat, and absorption coefficient vacant seat is 0.3, and if it is people occupy it is 0.4. Then wall in diffusive module and space between the module and ceiling, the surface area is given, area floor without seat, rear interior wall, rear ceiling, surface area is given, absorptive ceiling on side wall, ceiling reflector, stage front wall, diffusive side wall, stage floor, stage side wall. Then I said write the material name, which kind of material you should, acoustic material you should use to treat this area. So, what I said thumb rule is that stage area must be reflective. So, when I said the stage front wall, I should use the material whose absorption coefficient as low as possible. Suppose architecture said me those are the material I want to use in that auditorium. So, I can say that see that fiber cement board absorption coefficient is very low. So, I can use that in stage front wall. Stage floor, is there anything floor? Hard wood I can use in stage floor. Painted concrete I can use in the stage side wall. So, all those things. So, reflective part I design. Then if you see the rear ceiling and rear interior wall, rear part of the auditorium must be as much as possible absorptive. So, I have to see which material has a large absorption coefficient, acoustic blanket, wood fiber board. So, I can say acoustic blanket I can use in the rear interior wall, and rear ceiling I can use wood fiber board. So, depending on the choice aesthetic, I can choose the material from the market and treat that area. But thumb rule is that stage area must be as reflective as possible, middle area must be as diffusive as possible, and rear part must be as absorptive as possible. So, you put that material name in here, then you know that absorption coefficient, multiply by the surface area, you get the absorption in 7, then add them to get the total 7, then you can calculate the reverberation time if the volume is given, number of seat is given. So, acoustic volume, so it is not meter square, it is a meter cube, sorry, it is a meter cube, not square. Okay. So, volume is given, A is given. So, reverberation time is equal to 0.161 into V by A. B known, A known, then I estimate the reverberation time. Suppose the architecture said that my auditorium should be, reverberation time should be 1.2 to let us 1.5 second. Then after calculation I found it is coming 1.1. So, I have to readjust the material and decrease A, so that reverberation time is increased. So, front part of the stage I can use other material which has absorption coefficient is much lower. If it is much lower, then the A will be suppose 0.001 S into 0.01 S into 0.001, then A will be less in here. Okay. So, a much reflective surface I will be used. So, then I just changing the A, I find out the desired T, then my design is done. So, when you do a design of an auditorium, two things. One is that give a consultant to the architectural engineer that I require this kind of shape, because if shape is not this kind, then I cannot, auditorium acoustics will be not good. I require this kind of seat arrangement, I require this kind of ceiling volume, this minimum volume should be this, I require this kind of ceiling arrangement, this kind of ramping and this kind of seat arrangement, all things you can give that suggestion. These are the desired for a good acoustics. Then you know the surface area, then design is done. You know the surface area, then the design, then the user said I require a reverberation time 1.2 to 1.5. Then you have to choose the material, which portion you want to treat by which kind of material, acoustic material. So, there is a thumb rule is that reflective, diffusive, absorptive. So, that is thumb rule. You cannot put a glaze tile on the rear wall, because then the echo will hurt in that auditorium. So, rear side has to be absorptive. Now, you adjust the material depending on the aesthetic part is also very important. So, depending on the aesthetic and reverberation time, you adjust the material and design that auditorium. And also there is another one work is there, you should also give an advice that what kind of sound isolation is required inside the auditorium. Outside noise sound should not enter in the auditorium. So, there should be, suppose I make an auditorium and there is a glass window. Can it be possible? No. If it is a glass window, then outside noise should enter into the auditorium. I cannot avoid that ambient noise. So, ambient noise will be increases. So, that is avoided. Now, once I want to design a door, I just simply flash door. If the door is flash door, then outside noise is come inside. So, I have to treat the door also in acoustic treatment, so that the outside noise should not enter when the door is closed. So, I have to design the door also, I have to choose the material I have to design the door such that outside intensity, sound intensity should not enter in the room. You know that how the sound intensity is travel through the material. If there is a two boundary, then you know that it is depend on the L thickness. Suppose there is no thickness separation is not possible. I cannot make the door so thick. So, what I will do, I make a air gap inside the door, or I put a acoustic blanket in middle of the door. I make a two kind of wooden plate and then make an acoustic blanket here. Then the sound transmission will be reduced. So, that kind of consultancy you have to provide to the engineer. So, this is the auditorium design. Let us try a design of this kind of auditorium kind of things, real part. Then if you have any query, then you ask me, then if I know, I will answer it. Okay? Thank you.